So today we're going to do some additional practice with rational zeros. Here is a specific example that I want you to do. But the first example I put online, you're just going to copy that down, learn from it. If you have questions, ask me about it. For this problem, I've posted it, but I'm also going to actually going to put up a video for it. So we're going to find all rational zeros for this ugly looking function. Fx is equal to 128 x to the 6 minus 2. Oh my goodness. It looks crazy. So imagine if you had to actually solve for this. So here's the solution. We'll start by taking f of x and factoring out a 2 from everything. So you're going to get 64 x to the 6 minus 1. Okay, now, in order to make our life easy, we're going to go and let g of x equal 64x to the 6 minus 1. Now, we normally go and say, all right, we're going to identify the start and the s of this in order to find our s and p's in order to find our fractions, right? So we have a problem here because for the p-value is just going to tell us that we have plus or minus 1, and that's it, right? Okay, so there's factors of plus or minus 1 for -1. But then when we have 64, oh my God, this is the list that we have for all the possible factors of 64. So we have all of these possibilities for our s value. Oh my goodness, that's insane. So our s is easy, but our p value is crazily long. So you know what? This actually looks pretty hard. You know what? It actually looks ridiculous to find p over s. Could you just imagine having to go through all of those? That's ridiculous for our fractions. That's insane. So here's what we're going to do. We're going to take a look at that function, and what we're going to do is we're going to take a look at this function here, our g of x, right? Our g of x is this, right? So remember, it's g of x is 64x to the 6 minus 1, right? Let's try something a little easier. So something a little easier. So let's say g of x is still 64x to the 6 minus 1. But what would happen if we actually wrote it like this? Well, take 64 and take the 2x. So you could look at it as 2x all raised to the 6 minus 1. But then, if you're really good at it, you could literally take 2x, raise it again to the 3rd, and then square it. And the reason why we're doing that is because we want to be able to factor using difference of squares. Okay, so now if you think about it, our problem turns into, well, g of x is really going to be, well, 2x cubed minus 1 times 2x cubed plus 1. So now we have two factors. So now what we can do is we can take some time and break this problem up into two parts. Okay? So the one thing that you probably don't remember is how to do a difference of cubes. So I'm actually going to give you the formula for that so that you have a little less to think about for this next section. Okay? So just give me a moment. We'll set you up and we'll get her done. So here's an aside. I want you to remember this equation. This is an equation that you will use when you're in university. So if I have x cubed minus y cubed, right? The answer is the following. X squared. Oh, sorry, it's not that. It's x minus y in the front as our factor. And then you have x cubed plus xy plus y squared. Now, if I have x cubed plus y cubed, then you have the following. X plus y, and then you're multiplying by x squared minus xy plus y squared. Okay, that's it. So let's just go and fix this so we can see this as x squared. So we have x squared minus x squared plus y squared. So this is something that a lot of you guys, when you go off to university, you're going to have to remember a thing called a difference of cubes. That difference of cubes is a completely new concept, but it is important. All right, so make sure that you know how that you can use it in this case. So when we go and do this problem, we end up factoring this part here, and it turns into equals, well, 2x minus 1 times that big ugly thing. So you're going to get 2x all squared plus 2x and y, not y, but 1. And then you're going to get plus 1 squared. And then for the second half of our problem, for this part here, we're going to get the following. 2x plus 1 times, well, 2x all squared plus 2x, no, not 2x, minus 2x times 1 plus 1 squared. And now we simplify. So now g of x turns into 2x minus 1 times 4x squared plus 2x plus 1 times, well, 2x plus 1 times 4x squared minus 2x plus 1. So now to make our life easier, our problem isn't as bad as we thought it was going to be, right? So this is factored. Great. This is not. So why we can't factor it? We can't find something that's nice. So here's what we have to do. We're going to have to let the following happen. Let 4x squared plus 2x plus 1 equals 0. And then we use the quadratic formula. Save yourself some time and check this, the discriminant. If b squared minus 4ac, figure out what that is. So b squared minus 4ac is equal to, well, our b is 2 squared minus 4 times 4 times 1. So you end up with negative 12. Therefore, there's no roots, no solutions for that quadratic. So you can't factor. So can't factor it. But for the other one, let's check. Let's check. So there is a nice factor done, but now we need to check this one. So now let's check to see if we can factor from the quad formula again. So we're going to let 4x squared minus 2x plus 1 equals 0, and then we substitute it into not the entire thing. We're just going to use the discriminant. So we end up with b squared minus 4ac, and that's going to be, well, negative 2 squared minus 4 times 4 times 1, which is negative 12, right? So anytime we have a negative, that means for our discriminant, remember this thing here was called the discriminant in grade 10 and 11. If my discriminant was less than 0, therefore there are no real roots. So no real roots, really. And so therefore there's no solutions for this that we know. Okay. All right. So that's it, really. So you could continue on with the math, but you know what? I'm done. Okay. That's it. So for this work, this lesson, you're going to do the following questions. The following questions are page 158. And you're going to do numbers 25, 27, 31, and 35. Okay, so all that stuff is posted online. Good luck.